Hello guys, this is Jeremiah and I'll be your guide for today in vectors 2. We are going to tackle a question to simplify vectors and make it simple. So journey with me as we tackle this question, and if you have any query, anything to say, drop it in the comment section. I'll see it and work on it and prepare something. So today we are going to look at vectors to this question. It seems to be a simple question, but you have to be keen and see and solve things very well. So I'll be there to help you. So journey with me, and I know by the end of this lesson you're going to see it in a very good perspective, in a very good angle, and see vectors very sweet, enjoyable doing it, and I know you're gonna love it. So as we're going to begin with the question, and it reads as follows. It says that the following diagram is a trapezium AOCB or OACB, where OA is parallel to CB and OA is equals to 3CB, and M is the midpoint of AB. Given that OA is equals to 3A and OC is equals to vector C, expressed in terms of A and C, AC, AB, OM. Then B, line AC and OM intersect at X. The intersection point is here, the meeting point, such that OX is equals to H of OM, of the whole line. OX is this portion of the whole line, and AX is K of AC, which is the whole line there, where H and K are scalars. Then we determine the value of H and X. Let us dive into the solution. Now we are looking at the solution. So OA is equals to 3A, and at the same time we know that OA is equals to 3CB. From a view only, we can say that CB is equals to A. But also we can replace and say that if OA is equals to 3A, then 3A is equals to 3CB, and we come to a conclusion that CB is equals to vector A. So we are going to look for AC vector, and to get vector AC, we are going to use either two roots in the same question, and using the two roots in the same question to solve in order to get that vector AC. Looking at this, we are moving from A to C, and we can use root AB, then BC, but we do not have AB since we are looking for it also in the question. It's given in the question to be looked for, but we have AO and OC. And remember guys that if the vector is written as AC, it means we are moving from A to C and not C to A. If it is C to A, then it will be CA. So our arrow here points from A to C. So this arrow points that we have moved from O to C. This arrow points that we are moving from O to A. So if it is from A to O, then this arrow changes, points the other way. And if it changes, this was positive, everything changes, the vector changes. If it was positive, it becomes negative. It was negative, it becomes positive. Understood? So now AC will be given by AO, then plus OC. Understood? So AO, we've said that from O to A it was positive 3A, but now we've changed the direction from A to O, and that will be now negative 3A plus O to C. It is from O to C, and the arrow points, and we are given that it is vector C. This is the same as writing vector C minus 3A. The two are the same. So this gives us the answer of vector AC. Understood? Now we are going to vector AB. And now vector AB, we can get it through by moving from A to C, then C to B, or A to O, O to C, C to B, but that is a bit long and tiresome. So let us go through A to C plus C to B, and ensure the beginning letter is the first point, the last letter is the last point. Understood? So C, A, B, B. Now AC, we have it as C minus 3A plus CB, we got as A. It's the same as saying it is negative 3 moving towards 0 one time or one step. So if it is negative 3, then one step towards 0 we are going back. That is negative 3 plus 1. That is 1 minus 3. That gives us negative 2. So we have C vector minus 2A vector. We get the answer of vector AB as C vector minus 2A vector. Sorry. Understood? Then now we are looking for vector OM. Vector OM. So vector OM here is this point OM, and we have two choices, either O to C, C to B, B to M, but that is a bit long and tiresome. So we have the shortest rule, that is OA plus AM. And remember, our question says that M is the midpoint, Our question says that M is the midpoint. Understood? So M being the midpoint, M is the midpoint of the question at hand. So being the midpoint of the question at hand, we know that it divides it to a half. So this is a half of A, B. This is a half of A, B. A half of A, B, a half of A, B. Understood? So we have now our OM. Our OM, we've said we are going to get it through OA plus AM. Are we together? So OM is given by OA plus AM. Our OA, we know it as 3A. It's given already. And AM, we have said is it's a half of AB. Okay, so this will give us 3A plus a half of AB. Half of AB, we have it here as C minus 2A. Okay, so this is 3A plus a half C minus a half of 2, that is 1, so minus A. So 3A minus A, that gives us 2A plus a half C, and that gives us the answer of vector OM. So vector OM is 2A plus a half C, vector AB C minus 2A, vector AC C minus 3A. Okay, now to the elephant in the house, we have to express now we have ax, which is equals to KAC. We have ax, which is equals to KAC. Ax, which is equals to KAC. And OX, which is equals to HOM. And AX is equals to KAC, where H and K are scalars. So we are going to determine the values of the scalars. Okay. So I say we know that we have to express either this or this in either in two ways. Okay, in two ways. So if we are expressing this in two ways, we are going to express this direct, which is the first way, and the second way of expression, this one should be there. In the second expression, OX should be there. That is if we are expressing AX in two ways. But if we are expressing OX in two ways, then this is the first direction and it's the straight direction. And then in the second expression, AX should be there. Understood? AX should be there. Now let us use OX to express. We express it in two ways. Okay, let us express OX in two ways. Express OX in two ways. Our first way, we said OX is equals to HOM, and now this is OX1, and our OM is here, right here with us. Our OM is here, right with us. Okay, so that is H2A plus a half C. Okay, that gives me 2HA plus a half HC. Now this is OX expressed in the first way. Then now OX expressed in the second way. Let us call it OX2. We have in our OX2, we are going now to look the root. And remember, I've said that OX1 is the direct root. Okay, now OX2 is the root that we are going to include AX. Okay, now if you are going to include AX, we have to choose a root that AX must be included. Okay, so OX, to include AX, we are going to say OX2 is OA plus AX. Remember I said that the first letter should begin, the last letter should end. Okay, so OX2 is OA. We know our OA is 3A. Okay, and our AX is KAC. Good, awesome, brilliant. So this is fantastic. 3A plus K of AC. Our AC, where is our AC? Our AC is right here with us as C minus 3A, and all these are that's good. Okay, now this is 3A vector plus KC vector minus 3KA vector. Now remember the rule of like terms. Pick what looks alike, leave what does not look alike. Okay, so this is vector A, so they look alike. So we have 3A minus 3KA vector, then plus KC. Okay, this can imply, we can say that as we give the common factor, we remove the common factor out. Our common factor here is A vector, so that remains to be 3 minus 3K then plus kc vector. Okay, now this is ox2, this was ox1, this was ox1, this was ox1, we had it. Ox2 is now a vector into 3 minus 3k plus kc. Good. Now remember, all these are the values of ox, so it means ox1 is equals to ox2. So ox1 is equals to ox2. Our ox1 we had as 2ha. Our ox1 we had as 2ha. It's right here, plus a half hc. Okay, plus a half hc. We had it right there. So our ox1 is this, and it is 2ha plus a half hc vector. This is equals to a into 3 minus 3k plus kc. Okay, now sticking to the rule of picking what is alike, throwing what is not alike, picking what is alike, leaving what is not alike. Remember, as we stick to that, this is a, this is a, so this and this are equal to this. We say 2ha is equals to a into 3 minus 3k. Divide across by a, since it is common, it cancels. Then we create an equation that is 2h is equals to 3 minus 3k. So when this crosses, we have 2h plus 3k is equals to 3. That gives us a first equation. Okay, then we pick the next, that is c. See where it's common, c and c here, this and this, that is a half hc is equals to kc. C is common, it cancels. Then we are given us that k is equals to a half h. Okay, now here we have the value of k, straightforward, and the value of k is a half h, so if it's a half h, then we use this a half h as the value of k and replace to our first equation. Replace it to our first equation. Okay, so we say 2h plus 3. Our k is equals to a half of h. A half of h is equals to 3. Okay, so this is 2h plus 3 over 2h equals to 3. Okay, now 3 over 2 is the same as 1. Let me say it is 2h plus 1 and a half h equals to 3. So 2 plus 1, it's 3. So 3 and a half, we get that that is, if it is 3 and a half, that is 3 and a half h is equals to 3 if we multiply. Okay, now that gives me 3 and a half, that is 6. 3 times 2, 6, plus 1, 7. 7 over 2h is equals to 3. Then now divide by 7 over 2. If we divide or we multiply across by the value of 7 over 2, it comes here, or by the reciprocal, sorry, if we multiply across by the reciprocal, that is times 2 over 7 times 2 over 7. This cancels all, and we get our h as 3 times 2, 6 over 7. But remember, our k was a half of h. So our k will be a half of h, which is 6 over 7. By 2, 1. By 2, 3. And our k is 3 over 7. So our scalar values, we have h as 6 over 7. Okay. And our k as 3 over 7. So these are our scalar values, the value of h and the value of k, h being 6 over 7, k 3 over 7. And if you have that time, you can also confirm by replacing. If we replace 6 over 7 in one of the equation, that is h, we say 7 over 2 times 6 over 7. 7 and 7 cancels, 2, 6 over 2 gives us 3. So it is correct. So that is how vector question is solved, especially when you are going to express a vector in two ways. Like we've expressed OX in 2 ways, of which the first way was the direct way, and the second way, AX has to be included so that we find the value of K. Since if we do not include it, then we can't find the value of K, and also the value of H cannot be found. Okay, so that is how we solve vector question. Expressing OX in 2 ways is just that simple. So if this lesson has been of good help to you, kindly like, share, subscribe, and click on the notification bell. And I know by your support, I know that we are going to journey together and to make mathematics easier. Okay, so like, share, subscribe, drop down your comments, anything that you've seen that must be adjusted, drop down. Any topic that you want us to cover, drop down, and I'll be reading your comments. Prepare next videos according to what you've asked for. But for today, I was your guide, Jeremiah, doing vectors 2, a question, a KCSE question. So I wish you all success and good as you go through mathematics, as you learn mathematics. So thank you.